This video is a case study of the manufacturing processes used on a fire extinguisher. Three elements must be present for a fire to exist: oxygen, heat, and fuel. These three elements create the fire triangle, and one of these elements must be removed to extinguish the fire. There are 7 types of fire extinguishers: water and foam, carbon dioxide, dry chemical, wet chemical, clean agent, dry powder, and water mist. This video will look at a dry chemical extinguisher that uses monoammonium phosphate to extinguish the fire. The fire extinguisher is composed of several components itself: body assembly, gauge, valve assembly, handles, hose assembly, valve stem, valve spring, and pickup tube assembly. The body assembly is comprised of the body, base, and valve bung. After the 3 parts are made, they are welded together. Based on the appearance of the weld and simple part geometry, it was determined that gas metal arc welding was used in combination with an automation process. These methods would provide a lower cost for a high production rate. The body is made from low-carbon steel and uses a deep drawing process to form its shape. Deep drawing would be preferred due to the part geometry so that the material won't tear or wrinkle. The material would start out as a sheet and then be drawn to size over several steps. An alternative method would be spin forming. While spinning has a lower tooling cost, it would require more skilled labor and take longer than deep drawing. The base is also made from low-carbon steel and stamped to give it the shallow dome shape necessary. Stamping would be the most cost-effective method for a large production run of a part with this size and shape. The valve bung is machined from low-carbon steel rod. Based on the surface finish of the O-ring face and threads and the simple part geometry, it is determined that the part was CNC machined. The steel handles are formed using a stamping process. While there are no markings or visual evidence to indicate stamping, this process would be the cheapest method to use based on the chosen material thickness and shape. Plastic injection molded handles could be used as an alternative process, but would require additional machines and tooling and a redesign of the handles to ensure the strength of the part. The release valve is aluminum and appears to be an extrusion with post-machining processes. This method was determined given the difference in surface finish from the sides and the face. Using extrusion would reduce the amount of material required and machine time necessary. After cutting the extrusion to length, the bores and external features are machined. Alternatively, the part could be die-cast and post-machined. The valve stem body is a steel with clear zinc coating. Given the part geometry and cutting marks on the O-ring surface, the part was made using machining. The seating surface on the end of the valve stem is rubber and was done using a molding process to bond it to the body and create a smooth seating surface. It is unknown which of these molding processes was used, as there is no clear evidence. The spring is made from a spring steel and formed using a spring forming machine, which takes a roll of steel wire and wraps it into coil to the desired specification. The pickup tube assembly is comprised of the threaded end piece and the pickup tube. The pickup tube is a welded seam steel tube evident by the seam on the material. The ends are rough cut with a machined feature at the base. It is evident that machining was used based on the sharp burr left from the cutter. The threaded end piece is machined from hex stock steel, as evident by the surface finish of the flat faces compared to the base and threaded sections. It appears that the 2 pieces are pressed together and not welded or brazed, as there is no evidence of a joining process being used. The hose assembly is comprised of a rubber hose, plastic nozzle, and threaded end piece. Stamped aluminum hose ends are used to join the end pieces to the hose and crimped using a special die. The threaded hose ends are machined from aluminum round stock, based on the part geometry and difference in surface finish of the outer diameter to the threads and inner bore. The nozzle is manufactured using plastic injection molding based on the mold line and release pin marks. Rubber O-rings are used throughout the fire extinguisher to ensure proper sealing between the various interfaces. Due to the lack of markings, it is not possible to know the method used, as O-rings can be made by extrusion, injection molding, pressure molding, or transfer molding. Thanks for watching.